Today we're continuing to still talk about decimals and fractions. So way back to first, second week of school, top of a fraction, somebody with a hand, what was that called?
Numerator.
That is the numerator. What did the numerator tell us about a situation? Do you remember our definition for what a numerator was?
How many parts are there?
It had something to do with parts, but it had a different word that you didn't use there.
Parts and all?
Nope.
Parts counted?
It's the parts that got counted in some way. Bottom?
Denominator.
That's the, go ahead. Denominator. What is the denominator about?
Parts and all.
That's the parts and all. So the bottom tells you the parts and all, the top tells you what gets counted. If I wanted to demonstrate for you 3/4 of 12, here in my hands are 12 paper clips. So if I wanted to go about giving somebody 3/4 of this pile or showing you what that looks like, how would I show you 3/4? What would I have to start off doing?
You have to count it into
You'd have to see what number goes into 12 4 times.
Maybe. I don't think I'd even do math though. Just if I were trying to make 3/4 without even really doing any like add, subtract, multiply, divide, just what would I do with the paper clips to show you that I'm giving you 3/4 of them?
put them in groups.
How many groups? 4. I'd make 4 groups. So I'd go group, 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 group. Boom, 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 boom. I'd kind of divvy them up and I'd make 4 piles. And then I could ask you a bunch of questions about this. So if I were going to if I want to show you 3/4, I've got 4 piles here. What would I now do to show you 3/4? I got the fourths handled. How would I show you that you're getting 3/4? No, there is 3 in each pile, but that's a little deceptive. How could I show you that it's 3/4 of we're doing something with 3/4 of them?
You take 3 of the groups and move them.
Yeah, 3 of the groups kind of like go over there. So that's sort of like a way with items I could show you what 3/4 of 12 looks like. What we're going to try to do is use our imagination and answer some questions about things. So let me change this number and I'm going to run through this instead of what I have. So I'll go 3/4 of 12 items got counted. So if I ask you how many parts in all, we could look at my table, maybe you remember what I just did. How many parts did I make in all? 4. 1, 2, 3, 4. In a math homework situation, without grabbing 12 paper clips and spreading them around, where would you grab this answer from? The 4 parts in all. How did we know the parts in all? Just use the denominator. We're just going to grab the bottom. Whatever the bottom is, that's always going to tell you the parts in all. How many items are there? How many paper clips are there in each of those parts?
3.
3. We can see that right now. There's these piles of 3. If we couldn't see it with our eyes, how could we use the math to come up with the 3? I'll tell you it's not that 3, that's a coincidence. Why is there 3 in each pile?
Adds up to 12.
That's true. So what could we do with the numbers on hand to produce this? Like if I change this to be something like this, we don't want to just try to like quick know the answer. We need some sort of a math way that we can figure this out using the numbers on hand. How can we figure that out? Why is there 3 in every pile?
Because it's all equal groups.
That's true. So what math are we doing? Adding, subtracting, multiplying, dividing?
Well, dividing.
We're dividing. How can we use dividing to come up with the idea that there was 3 in every one of those groups?
4 divided by 12.
Yeah, we're going to take that bottom number and we're going to divide that into whatever number I gave you. Okay, if we take 4 and divide it into 12, that's telling us there's 3 things in each pile. How many of the parts got counted? How many of the piles, in other words, got counted in some way? Or from this, who tells us the parts counted in a situation? The numerator. So that's going to be 3 in this case. We're just going to use the top. The top tells you the parts counted. I moved 3 piles over there to show you that they were counted. So how many items got counted? How many of the paper clips got counted? 9. How could you do the math on that if these were bigger numbers and we can't just see that there's 9?
3 times 10.
We'll take the 3 times 3. If you take that second answer times the third answer, that's going to make that answer that we're looking for. How many parts, how many piles did not get counted when I played this game? 1. There's 1 sitting over here. If these were harder numbers, how could we use math to figure out that one of those piles, one of those parts did not get counted?
It's 3/4, so like if all 4 got counted, it would be 4/4.
So what math are you doing? Add, subtract, multiply, divide? Probably not. If there's 4 total and 3 got moved here, well, how do we know 1's over there?
Subtracting.
We're subtracting. We're going to take the bottom minus the top, would tell you that. And if there's 1 pile over here, how many items are over there?
3.
3. How can we figure that out with math if the numbers were a little bit harder to manage?
Adding?
Probably not. If there's 1 pile, that makes us have 3. What if there were 2 piles over here?
6.
There'd be 6. 3 piles, there's... So what are you doing? What math are you doing there? You're multiplying. We want to multiply the second answer times the fifth answer. If you did the second answer times the fifth answer, that's always going to pan out for you. As a check, how could these numbers help us check to make sure we got everybody? Anybody see a relationship between those numbers along with another number? That's true, but not what I'm looking for.
Did he say they're opposite?
I don't know what you mean by opposite.
Like, one's like how many you counted?
Yeah, how many you counted, how many you didn't. How could we use 9 and 3 to check and be like, okay, we got everybody? Yeah, if we add these up, they have to add up to make that original number. We started off with 12 paper clips. I'm either going to count them or not. So if we add those up and it adds up to where you started, that's probably a good sign. And what you're going to do in the homework today is you're going to be presented stories like this, but with numbers that are a little bigger that you probably don't want to grab. Let's say I decide to do 80 items and I tell you you have 4/5 of them. I don't think you want to go grab 80 items around your house and start making piles, okay? We'd rather just have a math system to do this. So I'd either write down the recipe if you think you might forget it, or just absorb the recipe while you're here live in the room, or as a backup plan, just watch the video later, I guess.
That's what I do.
That can work for you if you forget something. But parts in all is always going to come from the bottom. So if I say 4/5 of, name me a thing in the world. Any noun.
And?
What?
And?
Pencils.
Oh, I thought you were talking math.
Tell me a verb that you could do to a pencil.
Sharpen?
Sharpen it. So they're going to tell you like silly little stories with nouns and verbs. We can use any noun, any verb. It doesn't matter. They just like to tell you silly stories. But they'll ask you about parts. Then they're going to ask you about the pencils for this story. Then they'd ask us about parts, but they won't say counted. They'd, for this, say sharpened. For all of these, they'd say sharpened. Here, they'd be talking about the pencils. Here, they'd be talking about the pencils. So if we got 80 pencils, we're going to sharpen some of them. We're going to sharpen 4/5 of them. Parts in all. Somebody with a hand?
5.
5. We're always gonna use the bottom. The bottom will always tell you the parts in all. How many pencils would be in each of those 5 parts?
4.
No. There's 80 pencils, we're gonna split them into 5 parts. So how many pencils would be in every part or in every pile?
16.
16. How'd you do that?
Divided bottom into the,
Take the bottom into the number. We're always going to divide the bottom into the number to get the pencils in every part. 5 dividing into 80, that is 16. The parts, the piles of them that got sharpened. We got these piles of 16 pencils all over the place. How many piles, how many parts would get sharpened? The parts counted. Parts. 4. We're always going to use the top for that. Anything about parts, we're going to look to the fraction. Anything about the pencils has something to do with a bigger number like the 80. But 4/5 means 5 parts in all, 4 parts got counted. The pencils has something to do now getting close to like the 80 amount. But here's the cheat sheet of how you could just make that answer if you're like lost in space. So if there's 4 piles of pencils getting counted, and there's 16 in every pile, how many pencils does that make for your life? Like take a piece of paper, or it is going to be 64. How did you do that?
I just did 16 plus 16, and then I did 32 plus 32.
Okay, you can. You're trying to do 16 times 4 there is what you did to get that 64. Parts. Parts, we're looking at the fraction again. So there were 5 parts in all. There were 4 of them that got sharpened. So who didn't get sharpened?
16.
Parts not. It's 5 parts in all. There's 4 of them that got sharpened. So how many didn't? 1. We just need to take the bottom minus the top. There'd be 1 part left out. So how many pencils does that make? We got 1 pile of pencils that didn't get sharpened. How many pencils is that?
16.
16. Take the 1 times the 16, that makes 16 pencils. Just like thinking about that before we try it again, because that's slow going still right now, and we'll get it. Something there. Pick a number.
Like a fraction?
Any number, don't get too big.
25.
Oh, that's pretty big.
15.
50. Pick a number bigger than 15. Just don't go crazy.
23.
23. I'm going to say 230 over there. Pick me a noun.
Watermelon.
Watermelon. Something that you can do to a watermelon. That's a verb.
Bite.
Bite.
No. No.
So they go through a series of questions. They would ask you, how many parts in all? How many watermelons in each part? They'd ask you the parts that are bitten. They'd ask you for the watermelons that are bitten. They'll ask you the parts not bitten. They'll ask you for the watermelons not bitten. The story changes, the recipe remains the same. Parts in all will always be the bottom. The watermelons in every part is always going to be the bottom divides into the number. So I picked that number so that the bottom could divide into it. I didn't let you guys pick a random number because then we'd have gone all haywire. The parts bitten is going to be the top. The watermelons bitten, we're just going to multiply those numbers. The parts that got left out, we're going to have to subtract. And then the watermelons that got left out, we're going to have to do a multiply again. So somebody with a hand and some confidence, anybody take us through all 6? What do you think?
Parts and all is
It
23.
is 23, because we're always gonna use the bottom for parts and all.
10.
10, because we're gonna divide. 230 divided into 23 piles, there'd be 10 watermelons in every pile. And apparently, we're in a watermelon eating contest or something, 'cause that's a lot of watermelons for people to be biting.
150.
This
No,
one, not yet.
15.
That's a 15. Parts counted, that's always using the top, so 15 piles get all chomped up. So how many bitten up watermelons does that make? That makes 150 chewed up watermelons. So how many piles are there that are still safe and sound? There's 8 piles left over, 23 minus 15 that we could safely take home and feel good about them. So how many good watermelons are there still?
80.
There's 80. Then quick check, if we add these up, they either got chewed up or they didn't. If you add those up, it adds to 230 and now we feel pretty good about it. That went a lot smoother, but we had one person take over, so now I know one person can do that. Question about that? Let's grab a piece of scrap paper and have everybody try a round of their own, and then we'll compare notes. So, you just took a turn, you're busy. Pick a number, just don't get too crazy big with your number.
12.
12.
I got a scrap paper.
Go ahead, pick any number that's bigger than 12. 17. I'm gonna go 85. The 17 will go into 85. Pick me a noun. Any noun.
Come on, Tim. Come on. Something fun, buns. That's easy. Pick it out.
Yeah, I mean, it's hard when I'm like, animals.
Animal.
Oh my gosh.
And then a verb that an animal might be doing.
Oh my god.
It's like Mad Libs. What'd you have? Hunting. So then we want to know parts and all, the animals in each pack. I guess these are pack animals. These are wolves or something like that. So we've got the parts that are hunting. We've got the animals that are hunting. We've got the parts not hunting. We've got the animals that are not hunting. The story can change. Again, the recipe just remains the same. Give it a whirl. Just jot down your 6 answers, and then we'll compare notes with what people think. When somebody's done, we'll take your list, then somebody else will get done, we can agree or disagree with your list. Somebody else will get done, we'll have them weigh in. If everybody agrees, then we're probably right. Anybody have a full list? We got you a second ago. Let's get somebody else to give us a full list once we have somebody. Anybody ready to share their list? Have all 6? No rush. Whenever you have a full list of 6, we'll take somebody's. If you're stuck somewhere, this first one, just grab the bottom number every time. Second one's going to be the most math. You're going to have to divide. We're going to have to take the bottom, divide it into the number. That's going to give us this one. Third one's quick. Just grab the top. Fourth one, you're going to have to do a multiply, so maybe that's easy, maybe that's hard, but if we take the second and third answers multiplied, that'll make that fourth one. Subtracting the fraction should be fairly quick. That'll give us the left outs, and then a multiplication will get us that last one if you multiply the correct two things. So what do you think?
17, 5, 12, 60, 5, 25.
So there's a round on the board. I'm not saying yes, I'm not saying no. I said we'd get three people's opinions. If everybody agrees, we'll probably be right. Anybody want to come in and either agree or disagree with what that guy is saying?
I agree.
We agree. So we have 2 votes for that list. You agree. So we're 3 for 3. Does anybody want a moment still to try to create your own list? Is anybody still going? And then I will tell you, I agree with that. I agree with that list. That is correct. Is there anybody that had anything that you didn't get or you forgot or you don't quite understand what to do? One small twist, and then I'll tell you where the homework is. So some of the homework questions, they're going to give you fractions. We're going to do exactly what we did. What if I said something like 0.7? I throw you a 0.7. What are you going to do about that?
7 times.
Make it 7 tenths. What if I gave you a 0.75?
So if I wrote 100 yet, or
You could do 75 out of 100 and just go with it. What else could you do? You could do 3/4. You can get different lists on these for the ones where they give you decimals. So if somebody did 3/4, their thing would start with 4. But if somebody did 75 hundredths, their thing would start with 100.
Yeah, I was gonna
And
say
that's
with
okay.
this.
We could get some different things. Some people might reduce this a little bit to get like 15/20ths. And then that person's list would start with 20. Some of the answers would still agree. Some of the answers would disagree. These 2 answers, strangely enough, will always agree no matter what fraction you try to use. These 2 will have to agree. The other 4 would be like hit and miss. So when we exchange answers on the ones where the book or I give you a decimal, if you can reduce the fraction, no one cares. Reduce, don't reduce, it doesn't matter. But we're going to end up maybe with different lists from each other. So if we come into class and somebody's like, I got 6, somebody else says, I got 10, you might both be right. It's okay. So if I throw you the 0.7, you would need to go 7 tenths. That doesn't reduce, so there's no real wiggle room on that. Take like another minute, fill in another list, and then I'll tell you where the homework page is going to be. I think we got it now. It was slow going there at first, which it usually is. That's okay.
Yeah.
I think we got it straightened out now. We'll get 3 new customers. We just heard from,
I have a question.
okay, yeah, go ahead.
I don't know how 7 can go into 80.
It's not trying to. The bottom needs to go into the number. Always the bottom into the number. Got a list?
10, 8, 7, 56, 3, 24.
I skipped a level. What did you say at the end?
24.
It's a good sign maybe if we add these up. Those do add up to 80. That doesn't mean he's right 100% sure, but it means you got a shot. If these don't add up to 80, you are definitely wrong. If they do add up to 80, I'd say you're possibly or probably right, but we're not like 100% sure. But adding those up is a positive feeling. I already got your opinion.
Oh no, I was gonna agree.
Okay, yeah, I was gonna get 2 other people to chime in. Somebody that hasn't played around with this with us in the last 10 minutes. Anybody wanna agree or disagree with what we've got showing there? Let's pick on you because you're close. You get the whole way through it?
So good.
Oh, yeah. Okay, he agrees, so we've got 2 for 2. Somebody else that hasn't played in the last 10 minutes have an opinion? You through the list, you still got them?
I agree.
You agree with that? Okay, so 3 people agree, I agree as well. Anybody need any sort of help to understand what's going on with that? Okay, the homework, we're gonna start on 178. On 178, you can either look at it like it's 1 question or 6 questions. I don't know how you feel. Like whenever I threw up a round of this, did I ask you 1 question or did I ask you 6? I don't know. Depends on your point of view. But 178, there's an A to F, then it's 1 round of this. It goes A, B, C, D, E, F. Then we're gonna make a move to 180. 180 is gonna have another round of this, which is another A to F. So you could look at that as 1 question, or you could look at that as 6 questions, I guess. Then there's a set in the back, I believe, yes there is. There's a set CC. Set CC is one of our rare sets. It doesn't go 1 to 25, it goes 1 to 24. Why does it have to go 1 to 24?
Because it's just, there is but for
Yeah, it's coming 6 questions at a time, so this is gonna be 4 of these rounds to make it 24. So you could either look at this, I guess, as 36, or you could look at it as 6. They're basically gonna tell you 6 stories about trees and seeds and passengers and fire trucks or whatever they're talking about. It's the same, it's like the same questions every time. I don't remember if it's set CC or if it's another set later. We'll do this again another day when we start to do percentages. We'll do a set like this that involves percentages and the same story, kind of a pattern to it. I remember there's one day, and it might be today or it might be that future day, where they tinkered with the order once or twice in the set. I'm sure the A to F is in order. I'm sure this A to F is in order. I'm not sure on the CC if they're in order. So the way they usually will do it is parts, stuff, parts, stuff, parts, stuff. If you don't see them take turns between parts and stuff, they switch the order up. You just have to be a little careful that you switch your strategy up. If they start saying parts, 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 stuff, 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 just be careful.
Sean?
You have to like write out the whole.
No, you would just write a series of answers.
Okay.
And if you are like needing to long divide and use pencil and paper to long divide, just kind of show that in the area off to the side that you divided it. But if you're dividing in your mind, like 10 into 80 is 8, you divide that in your mind, just write down the 8. I don't care if you show work if you can divide it in your mind. But if they try to say 7 over 101 out of 80,800, I don't know if everybody can divide that in their mind anymore. Maybe you can, maybe you can't, I don't know, because it's 800. Like it goes in 8 with some bonus zeros, but that might freak some people out.
What do you do on the last step again?
Last step again is you take that second answer, the how much is in each part, times the parts that did whatever they did. I'd say the most important answer of the list is this one, because the second answer is on a quiz like a point by itself, and the second answer leads you to both of these. So if you're ever doing a quiz and you mess up the second answer, that's going to blast you for like 3 points worth of mistakes because 2 other answers relied on that second answer all the time. Anybody else, any kind of questions about things?